Okay, so now just to bring it back, why are we talking about this, right? The idea of behaviorism, one of the critical assumptions of behaviorism is that it makes the assumption that all learning is a result of conditioning, which depends on association and reinforcement. So association is involved in classical conditioning and reinforcement is involved in operant conditioning. So all learning is thought to be the result of those two types of conditioning. The other thing that it does is it focuses on observable phenomenon, i.e., behavior. And it also avoids speculating about unobservable mental states such as representations, right? And this is fine. There's nothing wrong with this, but it leaves very little room for cognitive science because cognitive science deals with unobservable mental states. So if there's no representations or internal states, then you don't really need cognitive science. Okay. And so we're going to talk about the big picture, the factors that led to the emergence of cognitive science. And one of them is mainly the limitations of behaviorism. So I'm specifically going to talk about Tolman's cognitive maps experiments. And long story short, these experiments or series of experiments will suggest that there is such a thing as mental representations even in rats. So, something as simple as a rat, you might think. So if representations are possible in rats, they're presumably possible in humans as well. So here's a schematic diagram of a maze that a rat would traverse through. So there is a start position for the rat, and the rat needs to learn how to traverse through this maze. And if they do, there's a box that may or may not have some food in it. All right. And then what you would do is you just measure how long it takes for the rats to learn how to get through the maze without any errors. Or you could just look at the number of errors, which is what we'll do. And so Tolman basically had three groups of rats. The first group of rats were given a reward, usually a pellet or some sort of food. And they were given this reward after completing the maze. So every single time they completed the maze, they would be given a reward. Whereas in another group, group two, there was no reward. So the group two rats would just try to get through the maze. And when they got to the end of the maze, there was no food or reward. And then there was another group, group three, and these rats were given no reward, but only for the first 10 trials. And on subsequent trials, they were then given rewards for completing the maze. So the whole idea behind behaviorism is that there should be absolutely no learning occurring unless there's reinforcement. So we could say that group one should be learning the most because they're reinforced on every single trial that they finish, whereas group two shouldn't really be learning it at all because there's no reinforcement. Their behavior is not being reinforced. And then the question is, what will happen to group three, where there's no reward for the first 10 trials? That's the main interesting point. And so here is the average number of errors as a function of the number of days or trials in which they completed the maze. And not surprisingly, at the beginning, on the first day, there was a lot of errors. And this is showing the no reward condition. You can see that learning is pretty shallow. There's not much learning going on, right? The number of errors doesn't decrease as a function of days very much. You can compare this to the reward condition, right? So whereas where both groups they start making the same number of errors at the beginning, right, on the first day, but when that one condition is when one group of rats are rewarded every single time they finish the maze, what you see is that they learn much faster, as evident by a fewer number of errors as a function of days, right? So that's not the surprising thing. The interesting thing is what happens to the rats who are reinforced on day 11 and beyond. So the idea is that in the delayed reward condition, if they're not being reinforced on the first 10 days, then there shouldn't be any learning going on. And it's true that for the first 10 days, they don't show much behavior that is consistent with learning, right? So this line right here is the delayed reward condition, and you can see it looks very similar to the no reward condition, right? Uh, However, on the 11th day, you find that there is a large decrease in the average number of errors. Uh, the decrease and the decrease is greater than those in the rats in the reward condition. So this suggests that the rats in the delayed reward condition, even though they weren't being reinforced on the first 10 days, they were still likely learning. So of course, this doesn't tell us whether they were learning the correct sequence of responses, turn left, turn right, or turns, but whether they were learning the actual layout of the map. We still don't know from these data what they're learning, which will be in the next video. But just on the basis of these data suggest that the rats are at least learning something, even when they're not being reinforced, right? This large reduction in error in the delayed reward condition suggests that the rats must have been learning something on unreinforced trials, on the first 10 trials. So if learning is a function of reinforcement, then rats shouldn't be learning until their behavior is reinforced. But what you find here is that on the day that reinforcement is given in the delayed reward condition, rats learn faster, indicating that they must have been learning something on the first 10 trials. And this type of learning is called latent learning. And latent learning shows that reinforcement was not necessary for learning and that the rats must have been picking up and storing information, again, either about the layout of the maze or sequence of responses that are required. But they were learning whatever they were learning when they were wandering around in the maze on the first 10 trials and not getting reinforced. So even though there was no reinforcement or reward, right, they were still learning. Okay, so in the next video, we'll answer the question of whether or not the rats seem to be learning the sequence of responses required to complete the maze, or whether they were actually learning the layout of the maze.